Hello math fans, Dr. Andy Loveless. Going to talk about lines in 3D and then I'll talk about planes in 3D and just give a little snapshot of some visuals and ideas. Then I'll follow up in a future video on the strategies for how you do problems, but you first have to know what you want. So let's talk about what you want. So in order to find the equation of a line in 3D, there are two things we want. So if a question says find the equation for the line in 3D such that blah, 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 there's a whole bunch of ways the information can be given, you immediately write the following things. In your head, you think, I need a point. So you say, I need a point, and I need a direction. That's somewhat the analog of point and slope in 2D. So I need a point that's on the line, and I need a direction vector. This is what we want. If we can find those two things, we can describe the line. I tell students the next thing you do is somewhere at the bottom of the page, you write X, Y, Z. And we use, because you can't do slope, we use what we call a parameter to go between. Slope is a convenient way if you have two quantities to avoid having a parameter, but with three quantities, it's better just to leave it like that. So let me adjust here a little bit. Sorry. So there you go. And what you do is you put your point here. You put your direction here. That's as simple as it is. Direction vector. Sometimes for this one it's less helpful than planes. But sometimes I'll have students draw the line, and I always have them draw the same line, and we draw a little vector, and we draw a point. So the vector might be A, B, C, and that's already more than I wanted to say here. Mostly I just want to talk about visuals and ideas in this video. So you put the point here, you put the vector here, so your answer will always look like this. Most of the time that involves three subtractions. So it's actually really fast. This is very useful. The hardest part for students is getting used to using a parameter, but it's actually great. But let's just focus the rest of this time on showing some visuals. So here's an example of 2 points in 3D. If you connect them, you get a line. We already know how to find a vector between those 2 points. And so that's exactly what we're going to do. That's what I mean by three subtractions, and we have everything we need. If we think in terms of vectors, what we say is we can walk out to the line. We call that the initial vector. So there's a bunch of little things you can say. You can say, let's walk out to the line. That's that gray vector in the picture there. Gray is weird. Let's change it to something else. Orange. You walk out to that blue point, and then you start to walk along the purple vector. And if you want to scale it, you multiply it times t. So this sort of looks like the equation of a line in 2D. And you say, that's how I'm going to get my xy points. That's just a vector way of saying what I've already said here. I think of it as just walking. Imagine the blue point is time 0, and the green point is time 1. So if you want to go to some other time, and right now I'm going to animate, that's time 3. So there's time 1. You can walk along and kind of draw your line. Now, normally I just do it, like I said, with the points there. But that's it. You can walk anywhere along there. There's where I am in 2 seconds. Here's where I am in 0 seconds. Here's -1 second. So we can walk everywhere along there doing this. That's it. So that's all I wanted to really do in this video was talk about the fact that if you want a line in 3D, you need a point and a direction vector. The direction vector just needs to be a vector parallel to the line. A few little follow-up comments conceptually. So you can have two lines that are parallel, and when they're parallel, we say they're going the same direction, meaning their two direction vectors are pointing the same way. I wanted to say that because that is different than something we're going to talk about in a second, which is skew lines. So two skew lines would be lines like this that are, I got another one of those gray lines there. Two lines like this, I'll get rid of the first ones. That we don't call that parallel. we just say they missed each other. They got really close, but well, maybe not. They missed each other. So that's skew. That's different again than parallel. Parallel basically means they're always the same distance from each other. Skew means there's actually one moment when they're closest. And you could use calculus to find out when they're closest if you wanted. It's a minimization question. But they never hit each other, no matter how you walk along them. And we could talk about walking along them. There's another possibility. So they can be parallel, which is this, exactly the same way. They could be skew, which is what we just talked about. They're not parallel, but they don't hit. And then they can intersect. That's the least likely thing to happen. And we'll talk about how when they intersect, they are not necessarily at the same points at the same time. And so we'll talk about what we mean by that. Let me give you match our colors. So we'll have to use what we say different parameters. If you use the same parameter, they don't hit. So you have one person walking this way, one person walking this way. They might run into each other. That's called a collision, but that's really rare. So we'll have to say, okay, are there different parameters when they're at the same place? That's really the logic of lines. Those are the things that come up. So you need a point and a directions, and two lines can be parallel, they can be skew, or they can be intersecting. All right, hope that's interesting.